Welcome back to today's lecture. My name is Fajobelu Atusi. I will be taking you through a quick tour of study section 1 with course code SOS 201 Introduction to Soil Science of the LAUTECH Open and Distance Learning for Agricultural Sciences option 200 level course materials. This course explores the fundamental principles of soil science and soil as the natural resources. Therefore, students will be introduced to the physics, chemistry, microbiology, morphology, fertility and management of soil, and to the processes driving soil formation. So the major soil types of the world and the classification will also be discussed, and the relation of major soil characteristics to soil productivity, conservation, and sustainability will also be addressed. At the end of this study section, you should be able to have brief knowledge on the soils and their composition. You should be able to understand the genesis and formation of soil. And lastly, you should be familiar with soil formation processes and the factors influencing soil formation. Let's discuss this learning outcome one after the other. Definition of soil. There have been several conceptions held about soil in the historical past. This has led to several definitions of soil by different people at various times. Several definitions range from very simple definitions to very professional definitions. There have been several conceptions held about soil in the historical past. This has led to several definitions of soil by different people at various times. So some of the several definitions range from very simple definitions to very professional definitions, which includes the following. Soil is a tiny layer of material on the earth's surface in which plants have their roots, and it is made up of many things such as weather, rock, and decayed plants and animal matter. Therefore, soil is formed over a long period of time. Also, soil can be defined as a natural body which comprises of solids, which includes the minerals and the organic matter, liquid and gases that occupies on the land surface. And it is being characterized by one or both of the following: ozone layers that are distinguishable from the initial materials as a result of additions, losses, transfer, and transformation of energy and matter, or the ability to support rooted plants in a natural environment. Also, soil can be defined in terms of its morphological characteristics, which is defined as unconsolidated surface material forming natural bodies, which is made up of mineral and organic matters and the living matter within them. Some of the concepts that affect the definition of soil in the past includes the following. Soil has a tiny mantle over the land surface. Soil has a medium for plant growth. Soil has a basic matter of the universe. And soil has a mantle of loose and weather rock. Soil has an organized natural bodies. The converted effects of climate and biological activity transforms parent materials by producing the physical and chemical energy to alter minerals and vertically redistribute material through the soil profile. So the effects of climate and biological activity is modified by topography, parent material, climate, biological activity, and time. Parent material is the initial mineral substance that forms a soil, and it is being derived from the weathering of rocks and may reside at a site of its origin or being transported from somewhere else to its current location. A soil is being formed from parent material at the site of its origin, which is called a residual or sedentary soil. Bedrocking weathering in place produce a stony, massive material which is being called sporolite. Several forces that can supply energy for transportation of parent materials includes ice, wind, water, and gravity. Topography. Topography relief or the soil or topography or relief is the slope and aspect of the land that has a strong influence on the distribution of soil on a large scale. And the two aspects of topography that influence soil formation are the altitude and the slope. Slope affects the amount of precipitation. Slopes affect the amount of precipitation that infiltrates into soil. Slope affects the amount of precipitation that infiltrates into soil versus which runs over the surface. Climate. Climate is the greatest effect of soil formation. It does not directly affect material translocation, that is the leaching or erosion for example, but it transforms indirectly the type and amount of vegetation supported by a soil. The two most important aspects of climate that has direct bearing on the process of soil formation are precipitation, that is the total amount of rain intensity and its distribution, and also temperature, that is the soil temperature. Temperature and the amount of water moving through a profile affects all the following. 1. It affects the amount and characteristics of organic matter. It affects the depth at which clay accumulates, and also it affects the type of minerals present, and also it affects the soil pH, that is the humid climate which tends to produce an acidic soil than do arid climate. Biological activity. Biological activity and climate are active forces in soil formation. Soil pedogenesis involves a variety of animals, plants, and microorganisms. Ants, earthworms, and burrowing animals, for example, mix more soil than do humans through plowing and construction. So plant roots remove mineral material from subsoil and redeposit them at the surface in leaf litter. So growing roots open channels through soil when rainwater can wash clay, organic matter down along this channel. So soil microbes decompose plant and animal debris, releasing organic acids. So this biochemical activity is the catalyst for a great deal of the oxidation or reduction and other chemical reactions in the soil. Time. Soils develop over time. Soil formation is a dynamic process where a steady state is slowly approached but only rarely reached. The rate at which a soil forms is related more to the intensity of other soil forming factors than to chronological age. Soil formation processes. Soil development begins with a parent material that has a surface layer being altered by vegetation and weathering. For example, a young coastal plain soil has relatively informed. For example, a young coastal plain soil has relatively uniform material throughout and is being altered only by a dark stained surface layer that has been formed by vegetation. So a more mature soil, on the other hand, shows evidence of removal and transport of surface layer of a clay to a subsurface layer called the horizon B. So there are two main processes that lead to the formation of soil processes, that is the loose and unconsolidated from rocks, and we have hard and consolidated. The first is the physical aspect, which does not involve chemical change, that is If we start with homogeneous parent materials, we have homogeneous soil. The second one is the chemical aspect, which involves chemical changes. These two processes occur simultaneously. We have physical weathering. It ensures that the rocks are broken down into smaller particle size. The processes in physical weathering include freezing, uneven heating, abrasion, shrinking, swelling, which break large particles into smaller ones. Roots of plants regenerate some pressure and cause rocks to break into pieces. Water and wind moving some materials cause them to score. Chemical weathering. This is the main process converting parent material into soil, while the bulk of chemical weathering is brought about by water. Organic and inorganic acid contained in water enhance mineral weathering. So chemical weathering may take the forms stated below. Hydrolysis, which is the chemical alteration of a mineral and the formation of its oxide through the action of water. Solution. This is the solvent action of water that has the ability to dissolve soluble materials or rocks due to the nature of acidic property it has. Hydration. In the case of hydration, water molecules are being added to mineral structure, but the water molecule does not dissociate. Significantly, the rock swells when water molecules get inside it, making it very susceptible to the activity of other weathering processes. For example, hydrates, hematite, hydrates, and dehydrates readily when water enters and leaves its internal layers. We also have carbonization. Carbon dioxide, which is being represented as CO2, may combine with water to dissolve marble, or it may combine with other compounds to form carbonate precipitates. We have come to the end of this first study section, and I hope you've learned one or two things from the figures section. Kindly read more in your materials for more understanding and explanation. Join me for the next study section. Thank you for listening.